In graph theory, a connected graph is a graph where you can reach any vertex from any other vertex by following a sequence of edges. Now, the connected pieces of a graph are called the components of a graph. So I've created 3 graphs here. Let's check out each one and try to determine if it is a connected graph or not. So let's look at this first graph right here. We can see that it has 5 vertices, A, B, C, D, and E. We want to know, is this a connected graph? So all that means is if we pick any vertex in the graph, can we get to any other vertex just by following a sequence of edges? So for example, if we consider vertex A, we can get to vertex B just by traversing this edge right here. Similarly, we can get to vertex C just by going across this edge. We can also get to vertex E all the way out here by going from A to C and then C to E. And we can also get to D by going from A to C and then C to D. Or we could go from A to B and then B to D. So we can see that it's possible if we start at vertex A, we can reach any other vertex in the graph just by following a sequence of edges. And if we repeat this process for every vertex, we'll find that we can go from any vertex we want to any other vertex in the graph just by following a sequence of edges. So we would say that this is a connected graph. And when we have a connected graph like this, we say that there's only one component of the graph. So the entire graph is considered just one component since the entire graph is connected. So that's our answer for this one. This is a connected graph and it just has one component. Now let's consider this second graph right here. So we again have 5 vertices, A, B, C, D, and E. But we'll notice, and it's probably pretty obvious right away, this is not a connected graph because, for example, if we consider vertex A, is it possible to get to vertex D or vertex E just by following a sequence of edges? No, it's not. We can see that there are no edges that would allow us to get from A to D or E. So this graph is a disconnected graph. We cannot go from any vertex to any other vertex just by following a sequence of edges. Now, for this graph, there are 2 connected pieces. So here's the first connected piece of the graph, and here's the second connected piece. So for this graph, we would say that there are 2 components of the graph. And by definition, every disconnected graph will have at least 2 components. So for this particular graph, we had exactly 2 components. Now let's consider this last graph, number 3 right here. So this one is a little bit trickier. We have 8 total vertices, and we want to determine is this a connected graph or not. So if we consider vertex A, is it possible to get to all of the other vertices of the graph just by following a sequence of edges? Well, let's say that we want to get to vertex H over here. If we try to traverse the edges, we'll notice that there's actually no way to get to H. So really, this graph, if we look at it closely, is just 2 squares that are kind of overlapping each other. So what we really have is 2 components, but we'll notice that they're not actually connected. So we can't go from A to E, F, G, or H. Or if you consider vertex H, for example, there's no way to follow a sequence of edges to get to A, B, C, or D. So although this graph is drawn in a way like this where there are 2 squares overlapping, this is actually a disconnected graph. And as we mentioned earlier, there are really 2 connected pieces of the graph. So there's this square right here that connects vertices A, B, C, and D. And then we have this square right here that connects vertices E, F, G, and H. So really there's 2 components of this graph. There's 2 connected pieces. So those were just a few quick examples of how to determine if a graph is connected or disconnected.